Given question, find the applied force P for impending motion of the block upwards if coefficient of friction is 0.25 for all contact surfaces. Self-weight of wedges may be neglected and the weight of block is equal to 150 kN. Let us understand given question with the help of diagram. We have to find out the force P which is applied on the wedges so that it will lift the block which is having weight 150 kN. If we observe these wedges is having same inclination, that is 15 degree with horizontal line, and these wedges are also in contact with the horizontal surface at its base. Now we will give the suffix 1 to find out the forces related to the surface of contact with wedges to the horizontal surface. So we will give here the number 1. We will use the suffix 2 to find out the forces which is in contact with the inclined surface of wedges with the block. So here are two wedges with 2 points of contacts. We have to give here for this surface of contact suffix 2. Now we will decide the motion of wedges as well as block. Now the purpose of the wedges is mentioned in the question. We have to lift 150 kN block in upward direction. So we will mention here the motion of the block in upward direction. Now applied force P on the first wedge is towards the right hand side. So motion will be in the same direction of the applied force P. So we will mention here the motion is also in the same direction of the P. Then the motion of the second wedge is same direction of the applied force P, that is towards the left hand side. So we have to mention here. Coefficient of friction is mentioned in the question 0.25. So we will find out what is the angle of friction. So we know that mu is equal to tan phi, and where phi is the angle of friction, so phi is equal to tan inverse of 0.25, that is equal to 14 degree. Now we will move to draw the free body diagram. Now we will consider the first wedge. For this first wedge, if we observe the motion is towards the right hand side, so frictional force will act in the opposite direction. So we will consider this lower surface. So frictional force will act in the opposite direction, which is parallel to the surface of contact, that is in the horizontal direction. So we will give here the suffix 1 F1. Now if we observe the inclined surface, then inclined surface is in contact with block. So we have to also show the frictional force which is in the same direction of F1, but it will be parallel to the inclined surface, and we have to mention it with suffix 2, that is F2. So I will mention here F2. Now we will mention the normal reaction. Now normal reaction is always in perpendicular direction of the surface of contact. So for base it is horizontal surface. So we will show here normal reaction N1 which is vertical. Now for this upper side which is inclined, now for this inclined line we have to show normal reaction. So we will show here one perpendicular line, and it is known as N2. Now we have to show the resultant. So how to show the resultant? So we know that resultant always makes an angle equal to angle of limiting friction with normal reaction. So it is easy for us to show the resultant. So with normal reaction N1 and N2 we have to make 14 degree angle. So here is the resultant R1, and angle is equal to here 14 degree, and here resultant R2 and angle equal to 14 degree. we will make here one construction. So if I draw one vertical line passing through the point of contact of this F2 and N2, then how to find out this angle? Now if we observe, for this horizontal line and this inclined line, angle is 15 degree. Now for this horizontal line, if we observe this vertical that I have made the construction line, this vertical line is the perpendicular line. And for this inclined line, this component N2 is perpendicular to this inclined line. Now angle in between these two perpendicular line is also same as made by this inclined line and horizontal line. That is, here we have to show angle equal to 15 degree. So that is the total angle made by R2 with vertical line is 15 plus 14 degree. Now we will move to the next wedge. Now here the motion of this wedge is towards the left hand side. So we have to show frictional force towards the right hand side, that is in the opposite direction. And in the same way, for this inclined surface, we have to show frictional force which is parallel to the surface towards the right hand side. So here is frictional force F1 and here is F2. Now we have to show normal reaction N1 which is in perpendicular direction. And here we have to show normal reaction which is in perpendicular direction to the inclined surface. So this is N2. Now it is easy to show the resultant because resultant makes angle equal to 14 degree with normal reaction. So we will show here resultant R1. Here is 14 degree and here is R1 and here also 14 degree angle and here is R2. Now we will draw one vertical line passing through the point. Now this vertical line, if I draw, then it is also making an angle equal to 15 degree because these two lines are perpendicular to these two lines. Now we have to show applied force P because it is mentioned in the question. So in the same direction we will show the applied force P. Now we will move to the block. So motion of the block is given. The motion is in the upward direction. Now weight. So weight is given 150 kilonewton. So this weight will act in vertically downward direction passing through the center. Here is 150 kilonewton. Now if we observe, this inclined surface of wedge and the surface of block are in contact. So we have to show the frictional force. Now if we observe, frictional force related to wedge for this side is towards the left hand side. So we have to show frictional force related to block, that is towards the right hand side, and it is parallel to the surface of inclination. Now we have to show normal reaction. So normal reaction will be perpendicular to this inclined surface. So we have to show here normal reaction. So we have to give suffix as a F2 and N2. Now we will show the resultant. So resultant make angle equal to 14 degrees. So I will show here R2 which is making angle equal to 14 degree. Now in the same way we have to show here this resultant. So how to show? Again for frictional force. So for this side, frictional force of the wedge is towards the right hand side. So we have to show the frictional force is towards the left hand side. So here is F2. Now we have to show normal reaction. So normal reaction we have to draw perpendicular to this inclined line and direction towards the block. Here is N2. Now it is easy to draw the resultant R2. So resultant R2 is making an angle equal to 14 degree with N2. Now if I draw the perpendicular lines, that is here one vertical line passing through these 2 points of contact. So here I will draw. Then here also angle equal to 15 degree because N2 and these two vertical lines are perpendicular to this inclined line and the horizontal line. So we will show here angle equal to 15 degree and 15 degree. Now if we observe for the block, there are three forces. So which are these three forces? Weight, then R2 and R2. So these three forces are passing through the center of block. So these are the concurrent forces. If we observe these two wedges, then there are three forces P, that is applied force, R2 and R1. So these forces also passing through the center of these two wedges, and these are the concurrent forces. So whenever there are concurrent forces and passing through the same point, that means concurrent forces, that means they are passing through the same point, then we can apply the Lami's theorem. To apply Lami's theorem, we will rearrange the forces so that their direction will be in the same outward direction from the center. So we will consider this is the center of block. Now this 150 kilonewton passing through the center in the downward direction. So we have to arrange from this center, direction is outward direction. So we will show here, and it is 150 kilonewton. Now we have to arrange this R2. Now this R2 is making an angle of 15 plus 14 degree with vertical line. Now if we observe, this is the direction passing through the center. So we will extend this R2 from this center, and we will mention here this is R2. Now what is the angle of R2 with vertical line? So it is making angle 15 plus 14 degree, that is 29 degree. So we will show here total angle 29 degree. Now we will rearrange this R2. So here is also R2 and it is making angle of 15 plus 14, that is 29 degree with vertical line. So if we extend this, then it is moving towards the center. So after center we will extend, and then it is making angle 29 degree with vertical. Now we will move for the wedge. So we can select any one wedge. So we will select this wedge. Now for this wedge, P is moving towards the center, but it is towards the left hand side. So we will show from this center, that is direction towards the left hand side, and this is the force P that we have to find out. Then we will show this R1. So R1 making an angle of 14 degree with vertical line. So it is also passing through the center. So if I again extend this, then we have to show this R1, and this R1 making angle of 14 degree, this vertical with this vertical. Then we have to show R2. So R2 is moving towards the center. So again we will extend this, and it is making angle of 15 plus 14, that is 29 degree with vertical. So we will show here, and it is R2, and it is making angle of 29 degree. Now we will apply Lami's theorem. So R2 divided by sine of angle between this R2 and 150. So what is this total angle? So we can write here 180 minus 29. Sine of 180 minus 29 is equal to 150 divided by sine of angle between R2 and R2, that is 29 plus 29. So this R2 is unknown. So sine of 180 minus 29, that is 0.48 multiplied by 150 divided by sine of 29 plus 29, that is sine of 58 is equal to 0.84. So answer is 85.71 Newton. Now we will move to the next. Now this R2 is known. So we can write here R2 divided by sine of angle between P and R1, that is 90 plus 40. is equal to, we have to find out P. So we will take P divided by sine of angle between R1 and R2. So how to find out? So we can write here 180 minus 29 minus 40. So when we solve this, then we will get the answer P is equal to 60.08 kilonewton. So here R2 is also having sine kilonewton. So what is the reason behind that? Because this weight is in kilonewton. So this weight is in kilonewton, that we have to write here. So this weight we have to transfer this same unit, that is R2 is 85.71 kilonewton and P is 60.08 kilonewton.